So we've got a new graph, j of x. It's an x to the 4 graph that you've never seen before. I like to call it the W graph. We want to translate it 4 to the left and 5 units down. So if you have something like this, what you're going to look for is some key points. Those look like key points to me. And then you're going to take each of those key points and move them. So if we want to move them 4 to the left and 5 down, well, this first one right here, 4 to the left, 5 down, will end up there. The other one that's at 2, 0. Oh, did I only go 3 to the left? Ooh, close. 1, 2, 3, 4. Yeah, you have to be careful with your counting abilities. Easy to make a little mistake like that. And this one, 4 to the left and 5 down, goes there. Can you see that you could also just sort of look and notice the distance between those 2 points was 3? So it's still 3 when you translate it over. And this one at the top is 4 to the left and 5 down. We'll go right there. We can draw our curve nicely through those points, put our arrowheads on our graph, and then we have our new equation. What is the equation in terms of the function j? So now we want to write an equation. Okay? Another key thing. It asks for an equation. An equation has an equal sign. So anytime a question asks for the equation, and the answer for this one is going to be y equals, two things happen. We moved it 4 to the left. That shows up as a plus 4 inside the function. And we moved it 5 down. So we're going to have a minus 5 after the function. Now, this is going to happen to some of you. You're going to get so excited about writing the answer that you're just going to write j of x plus 4 minus 5. Without an equal sign, mathematically, this is called an expression. Okay? The question asked for an equation. If you write an expression instead of an equation, it's one of the errors on the final exam that they're really looking for, and you lose a half a mark for that. So if it says equation, we want to make sure that we have that equal sign there, and we have something on both sides of our equation. And we're going to talk about that. That's going to come up in other times too, where you have an equation and you get so excited about doing your work on the right that you just stop writing stuff on the left. So we want to be clear. We want to take our time. We write y equals j of x plus 4 minus 5. The domain and range of each function, so we'll do our original one first. And I'm going to use only one notation this time. I'll switch back and forth so you can get used to seeing both notations. For the domain, with those arrowheads on the end, meaning that it just keeps getting wider and wider, the domain would be everything. Sometimes if you're wondering if the domain isn't everything, you can ask yourself, is there an x value that this graph never hits? There would have to be an asymptote drawn on our graph to show that it never goes past that, or there'd have to be a hole in our graph, but this graph has none of those things. So x can be everything. For our range, our smallest value is 0, and it goes up from there. Then when we look at our blue graph, when this has been moved left 4 and down 5, well, moving something whose domain was everything, left and right, will still have a domain of everything. But moving a range that was greater than or equal to 0 down 5 will now have a range greater than or equal to negative 5. So the questions you can do for practice for these ones are 8, 9, and 10.